Okay, we are rolling through these videos for the AP Summer Assignment. This video is on Section M. And Section M is going to ask you to do some verifications of some trig identities. Now, I know these are a little bit of a pain because, there's no one way to do every single problem. There's a little bit of thinking, there's a little bit of guess and check, proving you got to do as you go through these. But I put these on here for a reason. You gotta have your trig identities down. You really have to know how to use them, because sometimes seeing a way to rewrite a problem in the form of a trig identity is going to make the problem a little bit more simpler for us to do the calculus on or do algebra on as we go through the course this year. Okay? So, you do have that sheet of all the different identities. You hopefully have been making flashcards and have been studying them throughout the summer, just to remind you of what types of identities you need to know. You need to know the reciprocal identities, so things like the fact that sine of theta is 1 over cosecant of theta. Tangent is 1 over cotangent, things like that. You need to know your ratio identities, knowing the fact that tangent of theta is just the same thing as sine theta over cosine theta, and then cotangent would be the opposite, cosine over sine. You need to know your Pythagorean identities, so sine squared theta plus cosine squared theta equals 1, and then realizing if we divide that whole equation by something like sine theta, or sine squared theta, now you're going to get something with a 1 in a different spot, and you're going to have tangents, cotangents, secants, and cosecants, and the like in the other forms of the Pythagorean identity. Your sums and differences, so what does cosine of alpha plus beta look like? Your double angles, what does cosine of 2 alpha or sine of 2 alpha look like? They're really the identities that are going to be the most important for our study in AP Calc. Okay? But let's talk about how to verify some identities. So here's my strategy for any of these, and I have a couple that I'm going to do with you. I always start with the side that is more complicated. And what I want to do is I want to either use some known identities to rewrite that side, or I want to convert that side in terms of sines and cosines. If you can do that, that's really going to make your life a lot easier. So here's an example. I want to verify that tangent squared x plus 1 times cosine squared x minus 1 is just the same thing as negative tangent squared x. Alright, so I think you would all agree that the left-hand side is the more complex, so we're going to start here. I'm seeing some plus ones, some minus ones, and some squareds. I think this is going to be Pythagorean all the way. Alright, so we know that tangent squared x plus 1 using the Pythagorean identities can be rewritten more simply as secant squared x, so why don't we do that? Cosine squared x minus 1 is negative sine squared x. And now if you don't believe me, remember we have sine squared x plus cosine squared x equals 1. If we kind of flip-flop things, bring the 1 to the left, the sine to the right, we get cos squared x minus 1 equals negative sine squared x, and that's what we're substituting in here. Okay, so secant squared times negative sine squared x. Once I get to this point where I've kind of used all the identities that are obvious, this is where I want to start to convert things into cosine and sine and do a little bit of algebra. Alright, so secant squared x, using my reciprocal identity, that's the same thing as 1 over cosine squared x. Okay? I don't really have I have a reciprocal identity for sine, but I think if I rewrite that using cosecant, that's just going to confuse things. So why don't I just leave this in fractional form, negative sine squared x over 1. Alright, well I got two fractions. Let's multiply them together. Now I get negative sine squared x over cosine squared x. And oh my gosh, using my ratio identity, sine over cosine, that's tangent. So this just reduces to negative tangent squared x, and that's exactly what I wanted to verify. So we've done it. We've now just kind of proven that tangent squared x plus 1 times cosine squared x minus 1, using some algebra and some of the identities that we already know and are already in our kind of catalog of identities, will convert anything into negative tan squared x for any angle x. Let's look at one more. Let's try secant of x minus cosine of x equals the product sine x tan x. Okay. Alright, well, I'm not really sure which one's more complicated, so I'm just going to work with the left-hand side. Let's rewrite this in terms of sines and cosines. Well, I already have a cosine in the right term, but secant I know using my reciprocal identity, that's 1 over cosine. Okay, now let's do some algebra. Let's go back a couple sections from our packet, and let's get a common denominator, and let's really subtract these two fractions and make one fraction out of it. So to get a common denominator, if I take the right fraction, and I multiply top and bottom by cosine x, now I get 1 minus cosine squared x over cosine x. Okay, so far so good. Let's go back to the last problem. Sort of, kind of. 1 minus cosine x. We did something similar to that. Let's think about the Pythagorean identity again. Sine squared x, cosine squared x is 1. So sine squared x equals 1 minus cosine squared x. So now we have sine squared x over cosine x. All right, we're getting there. I can sort of see where it's coming from now. Let's break the fraction up. Let's decompose it into two separate fractions. So let's think of it as sine squared, or not sine squared anymore, excuse me, just sine to the first of x over 1 times sine squared, now why am I doing the squared? Another sine of the first x over cosine x. Think about it. I'll take a couple seconds and take a breath here to let you look at what I did and why that makes sense. If you multiply the numerators, you get your sine squared x back. If you multiply your denominators, you get your cosine x back. But now all we got to do is use one ratio identity that we know, and we have the answer. This is just sine x times tan x, which is exactly what we wanted to verify. So this worked. Okay? So give this kind of strategy a go. Like I said, every problem is going to look a little different because it's going to have different identities to use. It's going to have different functions in it. But if you kind of follow the same strategy that I've been following, work with the more complicated side, use your algebra, use the known identities, rewrite things in terms of sines and cosines that are not already written with sines and cosines, I think you'll start to see and go one step at a time and get where you need to go. All right, thank you for watching, and good luck on these problems.